All right, in this video, we're going to do some additional problems on, I guess we were working on polygons and quadrilaterals. I really don't remember what this whole chapter was about. There were so many topics, different kinds of topics as well. Without further ado, let's begin. We might have to think through some of these. Okay. What is the area of the isosceles trapezoid above? So how do we do this? Well, the area of a trapezoid is average of the bases times the height. Do we have the length of this space? We do not, so we got to find that. How do we do that? Well, do we know that this is a rectangle? Or at least, bare minimum, a parallelogram? We do, because a trapezoid, by definition, has one pair of parallel sides, that's these two, and because these are two verticals, they're parallel as well, so it's a parallelogram. Therefore, we can jump to the conclusion that this length is 18, EF is 18, and this we can use as 12 as well. Actually, it's isosceles, so we would expect this to be 12 as well. Okay. Now, how do we get this length? We can use the Pythagorean theorem. So what is AE is square root of what's 13 squared? That's 169 minus 12 squared is 122. Okay. So what is that? That's not right, 144. So that looks more right now. So this is square root 25, which is 5. Okay, so this length is 5, this length is 5 as well. Okay, now the area of the trapezoid is average of the bases, so 18 plus 5 plus 5, that's 28. Divide by 2 times the height, which is 12. The height is 12. All right, now simplify. This is what? 46 times 6. We're not calculating, we gotta do this by hand or in our head. That is 240 plus 36, 276. Okay, so answer is C. What's the area of the rhombus above? So how do we find the area of a rhombus? Well, a rhombus is a parallelogram, so the area of a parallelogram is base times height. Okay, base is 10, what's the height? The height is not 10. Don't get tricked. The height is always with respect to a vertical. So how do we get this? Does this look familiar? This is a 45, 45, 90 triangle. So if this is 10, then this height of the parallelogram, on this side of this triangle that you can imagine, is 10 over root 2. Or 10 root 2 over 2 if you really want. That should be fine for now. We can simplify later. Now, so base is 10 times height, which is 10 over root 2. This is 100 over root 2. Now let's simplify root 2 over root 2 to rationalize. So this is 100 root 2 over 2, which is 50 root 2. So the answer is C. Okay. In the figure above, EO is the mid-segment of trapezoid, TRAP, and RP intersects EO at point Z. If RA is 15, EO is 18, what is the length of EZ? Okay, so how should we approach this? This is the mid-segment. We probably have to use that somehow. Okay, if that's the mid-segment, RA is 15. I just marked that. EO is 18. Length of EZ. EO is 18. EO is 18. So we're missing, we want EZ. We probably want to get ZO. How do we get ZO? How do we get ZO? Well, let's see. This is a mid-segment. So do we have to find the length of this is the average of the two bases. Does that help us in any way? We don't know what this is. We know what that is, this entire length. We already know the entire length, so that might not help us. But okay, we have to use the fact that these two lines are parallel. Maybe let's mark that down. See, I'm thinking this live here, okay? Do I need this? Okay, let me just find it. We might not need it, but I'm spending so much time thinking, do I need it? Might as well just find it for now. Okay, so as I said, this mid-segment is the average of the two bases. So 15 plus TP over 2 is EO, which is 18. So TP is, that's 36 minus 15, which is 19. No, sorry, 21. Okay, so TP is 21. Does that help me now in any way? RAEO, what is the length of EZ? So since this is a mid segment, this is congruent to that, this is congruent to that. Does that help me? I'm trying to see what I can use to my advantage here. AEO. Oh, should I use, now that I'm thinking about it, do I need to use something to do with similarity? How do I know that things are similar? And which two are similar? If this is, so this upper trapezoid over here is similar to this one over here. All the angles are the same, are they not? Because this angle is congruent to this angle. They are corresponding angles. This is corresponding to this angle, and these two are the same, so it's similar. So can I use properties of similar shapes? I think I might be able to. So then, okay, maybe not the trapezoid, but these two triangles are similar. See, I have to think through this carefully. This triangle is similar to this triangle. So now maybe I can use similarity there. Okay, so RE over RT, the ratio of the small to the bigger, is equal to ratio of the small, EZ, to the bigger, TP. Okay, TP is 21. EZ is what we want. RE and RT, RE over RT, oh, sorry, the thing totally got cut off. Did not even notice because I'm deep in thought. Sorry. So RE over RT, even I drew it, this ratio is half. RE is half of RT because it's doubled. Okay, so therefore EZ is 21 over 2. There we go. This one's a little more challenging than I thought. See, sometimes you have to think a little bit more on these geometry ones. Versus for algebra, if you've really got the motions down, it's not bad at all. Okay? Okay, hopefully that was clear for this one. Again, I used the fact that the mid-segment, so this length is the average of these two lengths. Okay? So we were able to get TP from there. And this triangle, ERZ, is similar to this triangle, TRP. So we can use the properties of similar triangles to get the length of EZ. Okay? A rectangle that has a length that is 6 meters more than twice its width. What's the perimeter of a rectangle if the area of the rectangle is 1620 square meters? So, rectangle has length that is 6 meters more than twice its width. 6 plus 2w. That's how to represent it as an equation. Okay? Area is base times height, or L times W, which is 1620. Okay? And we can write L as 6 plus 2w. So 6 plus 2w times another w equals 1620. Okay? Now we can solve this quadratic probably, right? So what can we do? This is 6 plus 2w, right? Why don't we divide by 2 on both sides first? So this is 8, 10 is 3 plus w times w, okay? So then, how can we do this? Maybe let me just complete, I don't want to use the quadratic formula. And if we're not allowed a calculator, we gotta do this by hand. So why don't I complete this square? This is w squared plus 3w, okay? So 8, 10, I'm gonna leave a gap. That is w squared plus 3w plus 3 over 2 squared, and we have to add it over here as well. Okay? So this is w plus 3 over 2 squared is 8, 10 plus 9 over 4. Okay? So then, maybe we should just use the calculator for this. I'm peeking at my previous answer now because I won't be able to do this in my head. So if you plug into the calculator, w is 27 then. Okay? It's asking for perimeter, so this is not your final answer. So we need length as well, which is 6 plus 2w, plug that in. So length is 60, and now finally perimeter is 2l plus 2w. 2l plus 2w, and if you plug that into your calculator, that's 174. That's your answer. Okay, so be sure to answer the question that they asked. The figure above shows an equilateral triangle with side lengths of A and 3 squares with side lengths of A. If the area of the equilateral triangle is 25 root 3, what is the sum of the areas of the 3 squares? Okay. So, we probably need to find A. That's why they gave us the area of the equilateral triangle is this. What's the formula for the area of the equilateral triangle? Do you remember what it is? If not, you can easily derive it. I'm not going to derive it this time. I think it's this. A squared, side squared, times root 3 over 4. This is the area, which is 25 root 3. Okay? These root 3's will go away. So A squared is 100, which means A is 10. So A is 10, meaning the area of one square is 10 times 10, which is 100. So I didn't have to square root it, actually. So 3 of them is 3 times 100, 300. The perimeter of a rectangle is 5x, and its length is 3 over 2x. If the area of the rectangle is 294, what's the value of x? Perimeter is this, length is that. So 2 times 3 over 2x plus 2 times, let's call the width w, is 5x. And 3 over 2x, the length times the width, is 294. Okay? So, how can we solve this? Well, we can solve this for w and then plug it in there. Okay? So, this would be canceled, and then this is 3x, right? So, 2w is 2x. Okay? W is equal to x then. So, 3 over 2x squared, since w is x, is 294. Okay? Now, x squared would be, if you do the math, it's 196. So x is 14. That's the answer for that one. For this one, in the figure above was the area of region A, B, C, D. A, B, C, D, the whole thing, basically. Okay, so we just have to add the area of these two triangles. That's what I'm thinking. So what's the area of this first one? It's half the base, which is 4 root 3, times the height, which is 11, plus, what about this triangle? Half times 12 times, what's the height? We don't know. So we gotta do the Pythagorean theorem. To first get this, and then get that. So 11 squared plus 4 root 3 quantity squared. So that is AC squared. So AC squared is 11 squared, which is 121. 4 root 3 quantity squared, that's 16 times 3. Okay, which is 48, right? So 121 plus 48. And what is that? That is 169. So AC is 13. Okay? And now, hopefully, if you've been following along, you remember this is a special triangle. It should be 12, 5, 13 triangle, right? So this would be times 5. Okay? And now we add them together. That is 2, right? So that is what? 22 root 3 plus, this is 60 divided by 2, that's 30. Answer is A. Figure above, ABCD is a rectangle, BCFE is a square. ABCD, the whole thing, BCFE, this guy, square. AB is 40, BC, 16, AGD is 45. What's the area of the shaded region? This looks like a trapezoid, and it is because these are parallel, okay? So we need this length and this length times the height. Average of those two times the height. That's one way. Or you can find the area of the whole thing minus the area of this triangle minus the area of the square. That can work as well. Multiple ways you can approach this. Let's see what's the easiest. So if this is 16, then this is 16 as well because it's a rectangle. And therefore, DG is 16 divided by root 2. Okay? Sorry, not that. This is 45, 45, 90. So this is 16. And this guy is 16 over root 2. I don't know if we even need that, but that's that. Okay? So if this is 16, then actually we're good. Because it's 40. We can do that way. Area of the whole thing, 40 times 16, minus area of this triangle, which is half the base times height, which is half of 16 times 16. Okay? Minus the area of this square, which is, if this is 16, this is 16 as well, right? So minus 16 squared. Okay? So what is that? Can we plug into a calculator? Let me see. Okay, I think I did it a different way last time, so let me verify that this is the correct answer. 40 times 16 minus 256 divided by 2. That's 16 squared minus 256. So I got 256, and that's the right answer. So I did it a totally different way, I guess, than when I solved this before. Okay, that's one way to approach it. The figure above shows parallelogram ABCD, which the following equations represents the area parallelogram ABCD. Well, it's base times height. This is the height. Remember, it's the vertical height, not this height, the slant height, okay? So, how do we get this h? Which trig function can we use? Well, first of all, we can already eliminate that. It's that. I apologize for the jump in the video. I had to attend to something. And now I'm at a different setup, back to my old setup. But let's continue with number 9. We're trying to find the area of this parallelogram, so we need base times height, and we're trying to address what this height was. Okay, so we can eliminate choice A because base is 12. The height can only be one of the trig functions. It can't be both cosine and sine. Probably doesn't work like that, so cross that one out. Okay, what is tangent of x? Tangent of x is h over whatever this is. We probably don't want to use that because we don't know what this is over here, from A to this point over here. So cross that out. How about cosine x? Cosine x is this guy over 9, so that won't help us, but d will help us because sine of x is h over 9. So 9 sine x is h, which is what we want. This is our h, this is our base. So the answer is D. Okay. And I believe this is the last one. For this review, number 10, in the figure above, A, B, C, D, E, F is a regular hexagon with side lengths of 4. PQRS is a rectangle. Maybe that's key, rectangle. And regular hexagon, let's underline this. What is the area of the shaded region? Okay, so I'm already thinking, well, we can find the area of the rectangle minus the area of this hexagon. Okay, so how do we find the area of the hexagon? So I'll say H for hexagon. It's half the apothem times the perimeter. Okay, do we know what the apothem is? This is the apothem, by the way. Do we know what that is? We could find it because, okay, so this is a length of 4, okay? What's the area of each interior angle in a hexagon? I believe it's 60 if I remember it correctly, right? It was 6 minus 4 times 180 divided by, 6 minus 2, which is 4, times 180 divided by 6, which is 4 times, well, this is 30, right? So clearly I was not right. It's 120, it's double that. Okay, I remember it's 60 because probably when we bisect it, it's 60, okay? Or no, it's the central angle is what I was thinking of probably. But anyway, let's continue. So, this is the radius of the hexagon, by the way. So this would be 60, and this length over here would be 2 now. So what's the length of A? If this is 2 by the 30, 60, 90 triangle, this one would be 2 over root 3. That is our apothem. So half times 2 over root 3 times the perimeter. What's the perimeter of this hexagon? Each side length is 4. 4 times 6 is 24, okay? Which is 24 over root 3, okay? Now what's the area of the rectangle? Okay? Do we know the area of the rectangle? Actually, I did this math wrong now that I realized it. Before that, let's fix this. This is 60 degrees. So this is 2 root 3 over here. So this would be 2 root 3. This 2 would still be there, right? So that cancels with this 2. So it is 24 root 3. Okay, so now notice if this apothem is 2 root 3, that's the same length as ES over here. 2 root 3. Okay? And then same for this over here. That's 2 root 3 over there. So the height, or the height of the rectangle is 4 root 3. So 4 root 3 times, how about this length over here? It's 4 plus, what's this length over here? That's the question. Well, notice this is a 60 degree over here as well, because remember this is 120 total, that interior angle of the hexagon, and it's supplementary this one over here. So it's 120 120 plus 60 is 180, right? So this is 60 degrees, so this is a length of 2 over here. Okay, so this length is 4 plus 2 plus 2, that is 8, right? Alright, so clearly I did not do something right because this is also, oh no, this is 32 root 3. Okay, so what's 32 minus 24? That's 8. Is the answer 8 root 3? It is, okay. I thought 8 times 4 was 24. I'm like, that's totally not right. Okay, so this is one way to do it. Apparently, I'm looking at my previous work now. I did it a totally different way. So this is one way to do it. You could have found that you could have just gotten the area of this triangle, multiplied by 4, because it's all symmetric. That's another way to do it, instead of rectangle minus hexagon. And you could just use the central angle over here, divide by 2, which would have been 30 degrees. So same process though, except that you would get that angle instead to be 30. But this one, by properties of triangles, this would have to be 60 as well. So there's, again, lots of different ways to think through these and approach these, but if you do them properly, you'll get to the same answer. Okay? Hopefully this was helpful. As always, please like and subscribe if this has helped you in any way.